This is supposed to be easy. It turned out to be a little more complicated than that. Zen 4 to Zen 5 for gaming. How much of a performance uplift is it from generation to generation? The Windows patch, Windows update, has sort of clouded the issue a little bit. If you look at even AMD's own results and all of the major reviewers, and everybody came up with completely different numbers. And then Linux entered the picture. Zen 5 on Linux is a first-class experience. It's amazing. And so obviously everybody should start gaming on Linux, right? No, the reality is that gaming on Linux overall is an objectively worse experience than Windows in 2024. It's better than it's ever been, but it's still not as good of an experience on Linux as it is on Windows. Is it a good enough experience? I think so. But that's a different conversation. What I set out to do here was to start with a 7700X and move to a 9700X and look at the games that run on both Linux and Windows and see what kind of a performance uplift we get moving from Linux to Windows. To be specific, 24H2. At the time of doing this video, that version is not technically out yet. It is a version of Windows that improves performance for Zen cores universally. Zen 4, Zen 5, even all the way back to Zen 1, which also has added to the confusion of other videos. So we see different performance than has been previously reported, as well as better performance than has been reported, generally, for Zen 4, as well as Zen 5. It's an important thing to understand. Let's dive in. The other important thing to understand with this is that you can't look at the absolute frame rate. That's the whole point of testing Windows and Linux with the same set of games. You have to look at, okay, from Zen 4 to Zen 5 with a 7700X to a 9700X on Linux for this set of games, how much does the performance improve for those games at 1080p, 1440p, 4K? For this video, we're just going to do 1080p and 4K. And then on Windows, how much does the gaming experience improve moving from that 7700X to a 9700X for Windows 24 H2 that supposedly has all of the performance accoutrement? That's what we're going to dive into. That's what we're going to unpack. But it still doesn't make sense with Zen 5. Okay, Zen 5%, I don't really think that's fair given that the other experiences running Zen 5 on Linux, it's a truly breathtaking experience. It's amazing. Zen 5 at the end of the day, though, is built for server workloads. I don't think there was quite as much focus or emphasis on client workloads, and we see that in gaming performance. We could start with Shadow of the Tomb Raider to kind of illustrate what I'm talking about too with the cross-platform comparison. Alright, so if you look at this, it looks like Linux is going to give you a first-class gaming experience, almost 400 FPS with the 9000 series with Zen 5 and our lucky little Linux distro. Now keep in mind, Shadow of the Tomb Raider, isn't it like a decade old at this point? This is an ancient game. But yeah, we moved from 352 to 399 FPS. That is quite a percentage uplift. But on Windows, we moved from 275 to 285. So on Windows, moving from a 7700X to a 9700X, you can enjoy that much of a performance benefit uplift. But whereas on Linux, you get a higher percentage. And this is just for one game. And if you look at Borderlands 3, also an older game at 1080p, it's a kind of a similar story, 296 to 313 versus 327 to 342. Again, all we're doing here is moving from, again, 24H2, so it has all the patches, but for Zen 4 and Zen 5. And those patches benefit Zen 4 as well as Zen 5. And all we're doing is moving from a 7700X to a 9700X. And remember, those Windows patches don't really benefit Intel either. So this is purely a Zen thing. If you were doing this comparison, comparing Zen 4 without the Windows updates, it's going to look like Zen 5 has more of a performance uplift because the operating system is leaving a lot on the table. And if you just look at these two games, it still looks like Windows is leaving a lot on the table. But this is really super misleading, and I'll talk more about that in a second. Two other games that I really like to look at is Ashes of the Singularity and Cyberpunk 2077. Cyberpunk 2077 has been a weird one to follow because on Windows, whether you have virtualization-based security on or off, it really didn't make a huge difference in the 7000 series with Zen 4, but on Zen 5, it definitely made a huge difference, at least pre-patch, at least before Windows 24 H2. Now keep in mind 24 H2 is not really fully available yet. I'm using the pre-release version, but 190 to 205 is not a huge spread, and if we look at the generational uplift we can expect here? It's on the order of about 5%, no matter how you cut the cheese for your operating system, be that Windows or Linux. Similarly, ashes of the benchmark, it's around 60 FPS, 51 to 55, 60 to 64. It's very meh results. Far Cry 6 looks pretty interesting, moving from 167 to 201. Moving from 167 to 201 on Windows and 172 to 208 on Linux. These results are basically in line with one another. This shows that Far Cry 6 on Linux or Windows is pretty comparable. There's nothing really exciting or unusual happening with Far Cry 6. It's not quite margin of error, but Windows is doing a little bit better after the 24H2 update than Linux is, but 201 to 208, I bet if we tuned Linux, we could get that 208 FPS. But generally, these are in the same ballpark as one another. Baldur's Gate is pretty consistent. The lower city benchmark, basically we just load a save in the lower city. There's a fountain where some magicians are doing some magic and some special effects, and basically we just walk around the fountain and wait for the magicians to do their special effects. You'd think that the magic was RNG based, but if you take a long enough timeline of just walking around the fountain and then take the averages of that, or you do a bunch of runs and you take the run that is the run that is in the middle of the pack in terms of averages, you can get pretty consistent results. And 90 to 92 FPS to 118 or 119, Baldur's Gate's basically the same experience on Linux as it is on Windows, at least with game mode run. Horizon Forbidden West, this is one of those games that just doesn't run as well on Linux as it does on Windows, and this is, I think, a more typical gaming experience. If the game runs on Linux, generally the Linux performance is 5 or 10% behind. Make no mistake, gaming on Linux today, in the end of 2024, is better than it has ever been. It is fantastic. It is a perfectly reasonable experience, in my opinion. And if you put up with some of the headache of Linux, it has different kinds of headaches than Windows 11. And, the Linux's headaches are haphazard. Windows 11's headaches are deliberately adversarial. So it's a little different type of problem. But this is, I think, more typical of what you can expect comparing games when you're looking at absolute frame rates. 182 to 175, 127 to 140. Again, ZEN 5%. 1080p anyway. Red Dead Redemption 2. Red Dead Redemption 2 is a pretty similar experience. 165 to 206 FPS. Windows and Linux both benefit tremendously from ZEN 5. This is a pretty significant uplift for Red Dead Redemption 2. And it's kind of a middle-aged game. It's one of those games where it's actually older, but then it came to the PC platform later, and so it's not as old as it seems like it is, but you can have really high visual fidelity. Like, there's a lot going on there. And then Starfield. Starfield is a mess. Starfield is one of our weird little outliers, I think. So you move from 133 to 147 FPS on Windows and 94 to 99 FPS on Linux. This one is actually really hard to benchmark. If you don't watch it, you can actually get 5 or 6 benchmark runs in a row that are all really consistent with one another, but also completely not repeatable. The way that we do the benchmarking in Starfield is we load a save that's in a city that's around, there's like a park and some other stuff, and basically we just walk a path around the track for a minute. And then we do like 5, 6, 7 of those passes and try to take the one that's in the middle of the pack as our exemplar. And so it's still surprisingly variable doing that. Starfield is just not a fantastic game to try to benchmark. So maybe we should, I don't know. Wukong, I'm also not a fan of Wukong benchmarking, even though it has a benchmarking tool, which theoretically should be very repeatable. Black Myth Wukong does show a bit of a regression here on Linux, 110 to 108 FPS. This was pretty consistent, but I want to say it's within margin of error, but the reality may just be that the game is not super optimized. Generally, the 7700X was just slightly edging out the 9700X as well, which is annoying. Same kind of thing with Forspoken. Forspoken either performed worse with the 9700X, or on Linux they performed about the same. And that is a pretty significant performance delta between Linux and Windows. If you're into Forspoken, it's not as good of an experience on Linux as it is on Windows, at least right now. Now, this is just a sampling of what we're looking at 1080p. 1080p, theoretically, with 1080p, you should be more bottlenecked by your CPU than your GPU. The whole reason that people test at lower resolutions is to see what sort of generational uplift you get from your CPU. But the reality is that the CPU does actually make a difference at higher resolutions, 1440p and 4K. More of a difference than most people realize. And so it is important to also look at higher resolutions. So without going through every single 1080p result, we've also got Anno, we've got a whole bunch of other games. I want to sort of cherry pick some of the games that are the best case scenario games. And if we look at the 1080p uplift in our best case scenario games, things are looking pretty good for Zen 5 overall. We've got some significant performance gains on both Windows and Linux for Zen 5 across a whole bunch of games. Okay, Anno's a little weird. On Windows, you don't get much, but on Linux, you get plus 29%. That's pretty good. 30% in Baldur's Gate, as I showed you before. You know, Far Cry 6, Ashes of Singularity, Shadow of the Tomb Raider, Ryzens Forbidden West. Like, this is showing really good gen-on-gen gains. But these are also the games that show the gains the best. What about the games that show the gains the worst? It's like, well, we're looking at some, like, Forspoken, the worst regressions. I have a feeling there's going to be a game update to try to address this if there's enough people actually playing that game. Even Cyberpunk can show a regression when we're talking about 1080p and the high preset with the built-in benchmark. Black Myth Wukong, it's just a mess, as I was saying before. Borderlands 3, it's at the low end, 5% gains. F1 2023, 1.5 to 4.2%. Not a lot of gains. It's in that 5% range. A lot of games were in that 5% range. So what if we talk about 4K? We've got this whole suite of games. Maybe we should run some diagnostics at 4K and see what sort of an uplift we get from moving from Zen 4 to Zen 5 on both the Linux and Windows platform. And so if we run through all of that once again, let's just take a look at our best games on 4K. Ashes of the Singularity, 24%. Okay, that makes sense because it's a CPU-focused benchmark. That's not really telling you anything. I mean, it looks cool in a graph, but it doesn't really tell you anything useful. Starfield, 8.7 and 12.1%. Okay, I mean, it is kind of consistent between both platforms. But again, Starfield takes a lot of runs, and it's a manual benchmark, and there's a lot of fungibility in that manual run. So I don't really know that I want to trust Starfield 100%. Baldur's Gate 3 at 4K, plus 8 and plus 16%. Having played Baldur's Gate a lot, this is pretty real. It's pretty interesting. Plus 8 to 16%. Okay, I believe that. Far Cry 6, plus 16%. Again, played a lot of Far Cry 6. Yeah, okay, that makes sense. Cyberpunk Phantom Liberty, plus 5 to 7.8%. Okay. Red Dead Redemption 2, this is also real. Again, older title, but whatever. We've also got our problem games at 4K. And at 4K, Shadow of the Tomb Raider really doesn't show a lot of uplift. And this is actually what you'd expect. So at 4K, it's like even an ancient game like Shadow of the Tomb Raider is still bottlenecking the GPU. Okay, maybe. Horizon Forbidden West, negative 6.3% on Linux. Something ain't right there. F1 2023, it's like 3 to 5% gains. Black Myth Wukong, minus 2 and 3.5%. You get 4K gains on Black Myth Wukong. Okay, from the generational uplift. Forspoken, 8.3% generational uplift on Windows. Borderlands 3, plus 0.6%. At 4K, I would expect Borderlands 3 to have a little bit more of an uplift because it's such an ancient game that I would expect it to be more CPU bound even at the higher resolutions. But not really. And this also illustrates that the game, like the geometry of the game driver at 4K in Linux is different than the geometry of the game driver in Windows at 4K. If we talk about presentmon for capturing statistics in Windows, well, presentmon is not really a thing in Linux. Most people use Mango HUD. And so it's like, can you compare Mango HUD numbers to presentmon numbers? And you shouldn't. I mean, you probably could a little bit, but you shouldn't. And so you shouldn't necessarily take the absolute FPS from this video and run with them because that doesn't really tell you a lot because the platforms are different. I mean, it can tell you some things, like overall, the absolute frame rate is higher on Windows than it is on Linux, but there are outliers like Shadow of the Tomb Raider, which can happily run at 400 FPS at 1080p in Linux for whatever reason. And you can mess around with Windows and you can get it up to like 320 FPS. But you got to really pull out all the stops, maybe do some overclocking, kill some stuff in the background in Windows. Like you gotta really start modifying Windows other than just turning SVM off in order to claw back some of that performance. But that's just for that one specific game, and that might negatively impact other games. So it's not something I recommend or not something you should do. So what is the overall performance gain? Like when we look at this and we look at the averages and we look at everything else, taken as a whole, if we leave in the outliers, Linux is showing a 12% gaming performance uplift versus a 5.9% gaming performance uplift on Windows. And I gotta say, I was pretty happy to see 5.9% because Zen 5%, I mean, that's what a lot of other reviewers got from the gaming standpoint. Obviously, 12% performance uplift on Windows would be a lot more desirable, but 12% performance uplift on Linux, I think, is also a little misleading because of the outliers that are present. And we'll talk more about that in a second. At 4K, plus 5 to 6%, it's consistent between platforms. That does suggest that the bottleneck is elsewhere other than the operating system or anything like that. But to show performance uplift of plus 5 to 6% at 4K suggests that we might see bigger differences between Zen 4 and Zen 5 when the next generation of GPUs come. Or possibly if we do something crazy like run 720p benchmarks. But I don't think anybody's actually playing games at 720p. Like, I might believe somebody is gaming at 1080p in order to get 200 or 300 FPS or 400 FPS. Like, on a 200 hertz monitor, F1 2023 is actually, like, I'm not into driving games, but it is actually kind of interesting. But for this, you know, I don't know. But if we pull out the outliers, the weird ones, it's plus 9.2% on Linux and plus 6.8% on Windows. So Linux suffers a little bit if we pull out the outliers, and Windows benefits a little bit if we pull out the outliers. And we're settling into that, you know, about plus 6% generational uplift from Zen 4 to Zen 5, whether we're talking about 1080p or 4K gaming. And this, I think, this result makes a little more sense given Zen 5. A lot of the optimizations and a lot of the improvements in Zen 5 have to do with the kind of code that will be running more in a server context than a desktop or client context. Most of these games, almost all of these games, don't take advantage of things like AVX 512. And Zen 5 shows a slight memory regression. You know, we did our Linux testing and we did our Windows testing. The core-to-core latency, which is probably just a bug that's going to be fixed. Like, actually, I think the core-to-core latency is a testing artifact that only shows up in a couple of instructions, and so that may improve gaming. Like, the core-to-core latency thing, I think, is basically a red herring. Like, don't even worry about that. But the memory bandwidth, like the overall memory bandwidth, you were already constrained by the Infinity Fabric and this new quality of service algorithm. When you're just doing a memory benchmark, it shows a slightly reduced total amount of memory bandwidth because of whatever the quality of service algorithm is, I suppose, given that it's the same I/O die between Zen 4 and Zen 5. We saw that in our Linux benchmarks. That graph is very telling. It is a very minor regression, but it is just enough maybe to impact some of our stuff here. And for overclocking, I really wish we could push past, 2000 megahertz Infinity Fabric speed reliably across all of the I/O dies, across the Ryzen 9000 series CPUs. That might be enough to close the gap and bring this overall up another percentage point or two, because there's so many games that depend on badly architected memory access and things that are not really super optimized. I am surprised also that there is still as much of a difference between Linux and Windows as there is. It might suggest that Windows has some more performance on the table that it could eke out through further optimizations. It's not a lot. At most, it's 3% to bring it in line with Linux. But the thing you got to keep in mind is Linux overall average frame rate is lower than Windows, meaning that games on Linux in general don't perform quite as well as they do on Windows. And especially if you dig into 1% lows, and especially if you dig into microstutter and frame timing and that sort of thing. Game mode run is a better experience than any of the core parking nonsense on Windows, however. So it is possible that with game mode run, you could get into a situation where as an end user, it's easier and better and more awesome. And I could definitely see that future now, whereas maybe 5 years ago, that future was a little more cloudy. To be sure, Linux and Windows have annoying things. They have their own flavor of annoying things. There isn't one that is mostly free of annoying things at this point. But I'm surprised how good the gaming experience overall is on Linux. But there is still a lot that can be improved. And I still don't think we're going to see any miracle patch for Zen 5 that is going to bring it up 5 or 10% for gaming workloads. For everything else, it was already pretty awesome. And I'm surprised that Windows was holding it back as much as it was prior to these Windows updates, because there were some pretty significant deltas. But testing Windows, retesting Windows with the updates, 24H2, gen for gen gains versus Linux gen for gen gains is what I wanted to look at here, and I was still surprised. I was still surprised that Linux has as much of an edge over Windows, even in gaming workloads, as it does. But I gotta temper that a little bit with the fact that for a lot of games, the average frame rate in the game is lower overall, so it had more room to improve with the gen-on-gen update. I'm Whittle, this is Level 1, I'm signing out. You can find me in the Level 1 forums. Let's discuss, or test some other games, or maybe tweak the system. I don't know, we'll see. Alright, I'm signing out, let's see.